Okay. So what I was explaining was, first I explained what is reflection, right? So what you require to draw the reflected ray, this, let's call this as A, this as O, this as D, this is N, right? So there is a particular name for this ray. AO is called incident ray. You can call this as MM dash. Okay. So first you write MM dash is a mirror. It's a plane mirror or reflecting surface. So AO is incident ray and OB is reflected ray. What is NO? It's called normal. So what is normal? It is a perpendicular at the point of incidence. Okay. So perpendicular at point of incidence. So O is the point of incidence. So all these terminologies you should be familiar with. Then you'll understand everything. Okay. So normal is an imaginary line. Okay. So imaginary perpendicular. Like wherever you see a solid line, continuous line, it is a real line. This is real light ray falling in this direction, right? And OB is a real light ray, okay, reflected back in the same medium. It is air, air. So we said bouncing back of light in the same medium. So the incident medium is air, and it is reflected back in air. This is reflection. Okay? So everything, every word written has a meaning, right? Then, now we have written everything. So O is point of incidence. Now let's write the angles. So what is angle I? It's called angle of incidence. So what is this angle? It is AON. So angle of incidence is between the incident ray and the normal. So you cannot get angle of incidence without a normal. And there is a rule how to draw a normal. So on a plane surface, normal is perpendicular at the point of incidence. So foot of the perpendicular is point of incidence, right? Then how to draw normal at a curved surface or spherical surface? On a spherical surface, the normal is the radius. Because if it is a curved surface, it will make a sphere, right? So radius coming from the center to that point of incidence is normal. Remember that when we discuss these spherical mirrors, concave and convex, here also we require normal because without normal we cannot draw reflected ray. Now what is R? It is angle of reflection, which is angle BON. So angle between the reflected ray and the normal. Okay? And there is a rule. What is the rule? So there is this reflection takes place as per some law. And as per that law, angle of incidence has to be equal to angle of reflection. Okay? So what is the laws of reflection? Angle of incidence is equal to angle of reflection. This is one. So there are two parts to laws of reflection. And second is the incident ray, the reflected ray, and the normal, at the point of incidence. Lie in the same plane. So these are two parts of laws of reflection. Angle of incidence is equal to angle of reflection, and the incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. So let me demonstrate what the law means. Imagine the tabletop is a reflecting surface. Okay? And I mark a dot here. This is my point of incidence O. So what is the normal here? This. This is normal. Hold it. Okay. So this becomes my incident ray. Right? And this will be my reflected ray. All of them meeting at one point. So what is the plane? Plane of incidence. So this plane in which both these rays are there. Okay. If the plane is slightly different, let us say, you understand? Let's imagine this is a normal won't change. Normal is, let's imagine this is normal. So plane is changing here, right? So if the ray is incident in this plane, it will be reflected in the same plane. So imagine this is the plane, right? So this is the plane. Let's say this is the plane. If the ray is incident in this plane, then it will be reflected in the same plane. Now let us say I turn the plane, rotate the plane around the normal, like this. So is the plane changed now? So now it is here. Or the plane could be like this. If the incident ray is in this plane, the reflected ray is also in this plane. So plane can rotate around the normal. Is that clear? This is the meaning of the second part. Okay. So then what is regular reflection? There are two types of reflection, regular and irregular. Regular is, let us say, so this is a ray, right? There is a concept of ray and beam. What is the difference between ray and beam? Light doesn't travel as a single ray. Like when it is coming here, there are infinite number of rays traveling in all directions. So ray is basically a path of light. Single ray is path of light. That's a ray. But generally, light does not travel as just one ray. It travels as bunch of rays. So what is beam? It is a bunch of rays in a given direction. Okay. So whenever light is incident on any surface, it is not just one ray. There are so many rays traveling together, very close together. So like when you switch on a torch, what do you see? You see a beam of light. Okay. So all of them traveling in one direction. So in regular reflection, what do you have? So you have different point of incidences, right? O dash, O double dash. At each point, you will have a normal. And for each normal, you will have a reflected ray. So what you see in regular reflection is, okay, the incident ray, right, are falling at the same angle, of course, because they are in the same direction. So are the reflected rays. So reflected rays are also parallel to each other. Incident rays are parallel to each other. So are the reflected rays. Then it is regular reflection. So regular ray, reflected rays are parallel to each other. Or parallel to each other. ठीक है, रेगुलर में. अब मान लो irregular reflection क्या होता है? देखो. Imagine most of the surfaces, they are what? Irregular. Mirror is a specially designed artificial surface. But when you look around a tree, how is the trunk of a tree? Is it a regular surface? No. Are we a regular surface? No. We have rooms. If you see it with the help of a microscope, you will see valleys and peaks here. Right? Nothing is regular. All our surface have curvature, uneven, right? Everywhere. So, real reflection is basically irregular. The daily reflection which we observe in our day-to-day interaction with light is what? Irregular surface. वो कैसा होता है? देखो. So the irregular surface will not be plane. It could be like this. Okay. So some parts, if you divide these into very small pieces, then it may be plane in parts. But most of them will have curvature also. Right? So if this is a curvature, then its center, let's say its center is somewhere here, this part. So the normal, let's say the light is incident at this part, okay? So what is the normal here? Normal is the radius, okay? Now if the light is incident in this direction, incident rays are going to be parallel to each other. Let us say this. But is normal going to be same? No. So this was, let us say, the normal at. So how many point of incidence you are seeing here? 3. Let me draw the normal with the difference. These are the point of incidences. Now incident rays are parallel to each other. And let's say this was the center. So I said normal is radius. You draw the radius. When the normal is radius, when the reflecting surface is curved. Okay. So for a curved surface, the normal is radius. Now, what is the reflected ray? So you make angle of incidence and reflected equal. So this is the angle of reflection for the first ray. So how many rays? 2, 3 rays. Let's say this is my first reflected ray. Then here, ये मेरा second आएगा. ये क्या आ जाएगा? So are these rays, the reflected rays, parallel to each other? Are reflected rays parallel to each other? In this case, this is called irregular reflection, or it is also called scattering of light. Okay? So this is irregular. What you see here is irregular. Okay. So in irregular reflection, the reflected rays are not parallel to each other. Okay. It is also called diffuse reflection. Irregular reflection is also called or scattering of light. So light is reflected by the object in all directions. That is called scattering of light. It's a very important concept because real life is this. Okay? Real life thing is this. That's why in a plane mirror, right? So let's say somebody is standing here. Okay? And if you are standing at the angle of reflection only, then you'll be able to see the object. But in real life, anybody can see anything. Understand? So mirror mein, it's a regular reflection, whereas this is irregular, all right. Okay. So what have we learned? What have we learned here? What is the key condition required to understand reflection of light? What is required to understand reflection of light? Normal. What we have discovered is we need a normal. So on a plane surface, what is normal? Perpendicular. At the point of incidence. So here also, wherever the light is falling, it is point of incidence. Here it is 3 point of incidence. O dash, O double dash, O triple dash. What is normal in case of curved surface? Radius. Radius. Keep this in mind. Once you are clear with what a normal is going to be, everything then becomes very easy. Because without normal, you cannot draw I and R. I is known to you because I makes angle with normal. So once I know angle I have to construct angle R which is of equal magnitude as I. So I can construct the reflected ray. Once I know what is the angle of incidence, which I can know when I know what the normal is. So very simple. So how to judge what normal needed is depends on the type of the surface. So in this chapter, we'll be dealing with only 2 types of surfaces. Plane reflecting surface and spherical curve. Okay, only 2 surfaces. ठीक है? और दोनों surface का normal अपने को पता है. ठीक? अब मैं तुम्हें एक चीज पूछ लेता हूँ. चलो. Let's see how many of you have understood this. Let's say my surface is like this. ठीक है? And 2 light rays are incident. Can you draw the reflected rays for this? Let's say I give you the center for this is here. And the center for this is here. Okay. So, can you draw the reflected rays? Draw in the notebook. I would like to see. So this is a mirror, let us say. अलग type का mirror है. Okay, it is a before drawing the reflected ray, what you will do? First, you will draw normal. ठीक है? What is the point of incidence? इसका point of incidence है ये. इसका point of incidence है. And तुम्हें ये भी चीज ध्यान रखनी है. The reflected ray is always on the other side of the normal. एक साइड में इंसिडेंट रे और रिफ्लेक्टेड रे क्या होगा? दूसरे साइड. ठीक है. तो पहला काम क्या करना है हमको? नॉर्मल बनाना. तो नॉर्मल को हम सेंटर से ज्वाइन करेंगे. मान लो इसका सेंटर, ये जो कर्व है इसका सेंटर क्या है? ये इसका रेडियस हो. रिफ्लेक्टेड रे कहाँ जाएगी? इस तरह. ये हो गया पाई. ठीक है. ये हो गया आर. ठीक है. तो पहला तो बन गया रे वन का, रिफ्लेक्टेड रे बन गया वन डैश. रे टू का रिफ्लेक्टेड रे बनाओ. नॉर्मल कहाँ बनेगा इसका? तो नॉर्मल बनेगा ऐसे. पॉइंट, ये पॉइंट ऑफ इंसिडेंस है ना, तो नॉर्मल हमको बनाना है पॉइंट ऑफ इंसिडेंस पे, सेंटर से. नॉर्मल को एक्सटेंड करना पड़ेगा अक्रॉस द सरफेस. अब ये क्या है? ये क्या है? इसका रिफ्लेक्टेड रे कहाँ चला जाए? इधर आ जाए. ऐसे आ जाए. अंडरस्टूड? ये इस केस में नॉर्मल को दोनों साइड लेने हैं. तो ये कैसा मिरर है? ये है कॉन्केव. ये कैसा है? कर्व सरफेस इज बेंड इनवर्ड्स. ये कैसा है? कॉन्वेक्स. So reflecting surfaces bulged outwards. ठीक है. Here the reflecting surfaces bend inwards. Here it is bent outwards. समझ आ गया? तो एक बार ये फंडा क्लियर हो गया ना, तो बाकी इस चैप्टर में समझने के लिए कुछ नहीं. ठीक है. ठीक है. रेगुलर इररेगुलर रिफ्लेक्शन समझ में आ गया. तो ये कैसा एग्जांपल है? रेगुलर या इररेगुलर? इररेगुलर. क्यों? क्योंकि रिफ्लेक्टेड रे पैरेलल नहीं है, रैंडम. डायरेक्शन ऑफ रिफ्लेक्टेड रेज आर रैंडम. ठीक है. चलो. Now we have to study, like I said, only two surfaces, parallel and spherical. तो पहले plane and spherical. अभी plane करते हैं. Plane का हमने कर दिया. और next part. ठीक है, properties of image found by plane reflecting surface. तो अब देखो, so now let us take this as the plane mirror, a vanity mirror that you use every day in your home, right? Vertical mirror is an example of plane mirror or a reflecting surface, ठीक है? तो मान लो यहाँ पे एक ऑब्जेक्ट है, तुम यहाँ खड़े हो, मिरर में खुद को देख रहे हो, कहाँ दिखेगा मिरर में? खुद को देख रहे हो मतलब तुम किसको देख रहे हो? अपने इमेज को देख रहे हो। किसको देख रहे हो? मिरर में हम जब देख रहे हैं तो हम किसको देख रहे हैं? हम तो यहाँ हैं, तो मिरर में किसको देख रहे हैं? अपने इमेज को देख रहे हैं, ठीक है? So where is our image? Is it really on the mirror? Let's say this position is A, and let us say I am at a distance x from the mirror. This is my mirror. ठीक है? So where do I see my image? I see my image behind the mirror at the same distance. I see myself at the same distance x behind the mirror. This is the first property. So this is like object and this is image. O is the object, I is the image. So what is the first property? Image is at the same distance behind the mirror as the object in front of it. The first property होगा, देखो. Have you written all this? No? Have you understood the concept? Okay, so just retain all this in your head, because in book it is given in slightly lengthy language. That's why I keep insisting that you should take notes. It will save a lot of your revision time. And when you draw the diagram, this chapter is full of diagrams. Without drawing, you will not get practice. Okay? So have you written all that? Right. Everything has to be written. First write all this, one step at a time, then I'll explain further.
Sir, washroom जाओ.
क्या करेगा?
काम है.
ठीक है. No, it's not like it. You still need help, right? Some kids, are very everywhere they need some help. Okay, so are we good till here? Hello, done? Everybody? All written? All understood also? Okay. What I did not write in the diagram? I've captured everything.
You didn't mark what is the incident.
I think I've written. The meaning should be clear. This is how you should also prepare your notes. You will start enjoying it because once you start understanding the meaning, it becomes fun. It's no more, cryptic. Okay. So in this, so far we have discussed only one property. What is that property? The distance or the position of image where it is obtained. So what is the position of image? What is the position of image? Behind the mirror. So this part, behind the silver, wherever the silver painting is done, okay, that is the behind part. And where the reflection takes place is called front. Okay, so this is behind the mirror, this is front. So where is the image obtained? Behind the mirror. Okay. So whenever image is obtained behind the mirror, the type of image is virtual. Okay, so let's write down the properties. So properties of image. First property is position of image is behind the mirror. At the same distance as the object is in front of. Position of image is behind the mirror at the same distance as the object is in front of it. Okay. So there are three properties of image: its position, then its nature. Okay. Nature of image is virtual and direct. It is called upright. So when you see yourself in the mirror, right, you're standing like this, head here, foot here. Image also, head is up, foot is down. So it is upright. If the image was, let's say this is the image. So this is virtual and upright. Mirror is in between somewhere. If the image was like this, okay, in some cases image is inverted, right? So you will see that when the inverted image takes place. But in case of plane mirror, the image is virtual and upright. So when do we say the image is virtual? When it is behind the mirror. It is virtual and upright. Correct. It means one and the same thing or upright. So virtual image is always upright and it is always behind the mirror. The other type of image is called real image and it is always in front of the mirror. Okay, but you can't obtain real image by using plane mirror. It is obtained in concave mirror and that image will be inverted. Okay, so I'll explain you the difference between the real and virtual image, but first write down this nature. The third property about the image is its size. What is the size of the image? Is it same as object?
Yes.
Yes. Size of image is same as object. Okay? So when you see yourself in plane mirror, your image is of same size. You don't look bloated or you don't look shrink. Okay? Like your image is not enlarged or diminished. You see yourself as same size. There are mirrors which will show enlarged or diminished, like rear view image in the car. Full truck will appear inside the mirror. Full truck. So the image is now diminished. That is why you are able to see the entire truck in a small area of the mirror. So that is not a plane mirror. It's a convex mirror. ठीक है? ऐसा होता. अगर वो concave होता तो कैसा दिखता? ट्रक उल्टा दिखता तुम्हें. कैसा दिखता? उल्टा. ठीक है? हाँ?
ट्रक के नीचे का
नहीं, जो तुम डायरेक्ट जितना देख पा रहे हो मिरर में भी उतना ही दिखेगा लेकिन उल्टा दिखेगा. फनी ना, मतलब इमेजिन तुम मिरर के सामने खड़े हो बोल रहे हो. Have you seen that in fun and fair? Like in rural areas, there is no concept of now there are malls everywhere. This way you have, multiplex, moviplex. But in old times, the entertainment source was only circus and fun and fair, where they used to have this funny mirrors, where when you walk in front of it, suddenly you'll appear fat.
Yeah.
Then you'll appear dwarf. And you look at your image and start laughing, the way he's laughing. He's laughing without saying, so, okay. Then what you see is, you will see yourself opposite also, upside down. So they are basically different types of mirrors. Okay? So I don't know how many of you have been to such fun and fairs.
I've seen them.
Then there used to be circus. Have you seen circus? Live circus?
Yes.
Exhibition ground. When there was no exhibition ground, before you were born, it used to be a plain ground. Now it is an exhibition hall. Whole washing station has come up in front of. There was nothing. It was plain. It is made on reclaimed land. It was all part of sea. So dumping ground, dump karke, the land has been made. So that is what reclaimed land. And on that, this washing station structure and all the other stations have come up. We are standing where it was water, backwaters, waters.
No.
So we have made all these structures on reclaimed land. Now we are making coastal road in a reclaimed land. It's now standing inside sea. And this Mumbai city was a constellation of islands, right? And it has been connected via railroad, rail bridges and road bridges. That's how it has come into being. Okay. But New Mumbai is now connected with mainland. So we can really expand right till Pune. Okay. So, and we got an airport. Catch it.
Yeah.
It is operational. Are the passenger flights
No.
taking off?
December.
Starting December.
December.
Cargo is operational now, right?
Yes.
Yes,
Yeah.
it is. Cargo
That
is.
too only domestic flights are from December. International को और भी time लगेगा.
अरे अब time नहीं लगेगा, देखते जाओ. Start is key. See, once people start enjoying the benefits, then they want more. Right? I was at Worli Seaface Promenade. Did I say that? This Diwali, we got some kind of this. Huh?
He said he used to work at a government office.
Not government, corporate. Big people. When you start paying attention to what I say, you got it all wrong. Not government office. I used to deal with governments. The solution that we used to offer, our consumers were everybody, government, railways, airlines, banks. I have established, like, we have a role in the data center of SBI, Velapur. They have a huge facility, HO, head office. So the data center are running on the servers, which we have also provided. There are so many vendors who provide. Every vendor provides to SBI. These are big buyers. Sabka data hai वहाँ, BKC and all. So you will need little more growth to understand what I'm talking about.
Yeah, phone.
Yeah, it is hampering his listening. This is the reason you could not absorb. बंद करो सब मोबाइल. लेकिन बैठे मैं भी बंद करता हूँ तो मेरे को ही गाली पड़ी.
There are Instagram notifications.
Put your mobiles on silent mode.
Oh yeah, my mom was.
Let mom take a break
Yeah.
and let you study.
Yeah.
Let her know because of her you are not able to study. Put it on silent. Okay, just kidding. हाँ, नाश्ता चाहिए भाई. तो क्या बता रहा जैसे घुमा दिया.
Worldly.
हाँ, Worli Promenade. Have you been there? Reclaimed land. तो मुंबई अभी इसी में ग्रो हो रहा है ऐसा बना देगा आर्टिफिशियल. And we have made metro network by digging tunnel underland. So we have underground metro now, almost more than 30 kilometers of tunnel, starting from Cup Parade to Seeds. Seeds is our software export zone. This is where the work happens, software exports. Okay. And Cup Parade is South Mumbai, south to north. Okay, there is big network of metro getting constructed. More than 11, 12. Better than New York now. Go, Rome. You'll be proud. It's called the Aqua Line. It's the third metro line. First one was connecting October to Warsaw. Have you taken metro ride?
Yeah.
Who has taken?
Yes. Not in Mumbai.
Go, become familiar with your city. It has a lot to offer.
I have not.
The first underground metro train was in Kolkata. Okay. But that is on the rakes and all, although it is air conditioned. But this one is really modern. I think it's also driverless.
No. First, like it is a trial.
Is it driverless or metro?
Yeah.
Just check it out.
Yeah, it is. But nowadays, like there are some, like what do we call them? Drivers for safety.
Or so come on, yeah. Drivers are not safety. Okay, that's the problem. Human error. We
Yeah.
are prone to human error. Right? Machines are also prone to.
Yeah.
But if you maintain stable power conditions, machines go wrong when their potential difference is not stable. You understand? You understand how important it is? Imagine this is a supply and it is fluctuating. What kind of lighting you will get? It will flicker all the time.
Disco.
So the stable power supply is a key requirement for any machine to function normally. Machines go wrong only when your supply is affected. So a driverless train is a lot safer than a human driver if the power conditions are maintained properly. Then the software corruption will not take place and it will function as planned. So the first driverless metro I experienced was in Dubai. And I remember the date. It was 888, right? 8 August 2008 is when the metro ran in front of me. And they have kept the date also very iconic. 888. See, this is how people decide about, inaugurating certain services. आज इतने साल हो गए, still I remember that. The whole of Burj Khalifa that opened in front of me, Wasi station. So you are really standing in, you are witnessing a veteran, old guy, right? सब कुछ हमारे सामने बना है. So वैसे ही तुम्हारे सामने भी बहुत कुछ हो रहा है. जैसे Worli Sea Promenade has come up in front of you. Yes. Come on. Who told you that? Sardar Patel, in whose remembrance the Statue of Unity has been erected, he is an iconic figure. You know what Statue of Unity is telling you about? About Sardar Vallabhbhai Patel. Who was he?
I don't know.
First Home Minister, I think, of India. India's Home Minister, right?
Got unity to among all Indian states.
Yes. The whole of India, as you see today, as one nation, is due to his efforts. Okay, so know some history. No correct history. Okay, no correct history. How many points have we discussed about reflection of light? The image? 3. One more.
That alphabet.
The image is laterally inverted. What is the property? Image is
Sir, my go to washroom.
okay.
Don't drink the water.
अरे सात्विक तो ऐसी हरकतें मत कर.
The taste is bad, right? Who is suggesting don't drink the water? Taste is bad, right? Huh?
No idea.
You licked the water there. How did you drink? Go on.
And by the
Don't spoil habits of your
Famous tap water.
classmates.
Yeah. Correct. Famous
Image is laterally inverted. What does it mean? Okay, boys.
tap. You say
What is the meaning of lateral inversion?
It is inverted from the center.
Yes. Horizontal flipping. Horizontal flipping. Left becomes right and right becomes left in the image. Okay, like if you do like this in front of the image, what do you see? You will see this as this. Okay, so for example, if I put alphabet E in front of the mirror, I will see that as this. Oh, it is looking magnified. So exactly same size. This is the problem. Okay, but if the alphabet is this,
E.
And remain the same.
although it has, since it is symmetric, it appears the same. But even that is laterally inverted.
Yes.
Okay. So lateral inversion is evident here. Okay, pay attention now. Lateral inversion is evident when the alphabets are not symmetric. But if it is symmetric, then you can't notice. Okay. That's why ambulance is written,
Ulta.
yes, horizontally flipped. Each character is horizontally flipped. And that's how it appears, the image appears straight.
School was maybe लिखा रहता है वो van van. Van
Because
will get school bus.
school bus is carrying dignitaries like you. So to save you, right? The person driving ahead of you should know that there is a school bus, so you should not abruptly change the lane.
School
Okay?
van,
Van,
school
bus, whatever. It is to alert the driver ahead that he should not abruptly change the lane. That causes accidents. Follow lane discipline. Okay? It should be ingrained in your head since childhood. Our nation is one of the countries with baddest drivers. Baddest.
Van.
Worst. Baddest, is it a word? Worst.
Worse.
Baddest. This is what happens with English. Worst drivers. कौन है? लोगों को पढ़ाते हैं, इंग्लिश में पढ़ाते हैं हमें.
Mother's wife's mother.
I know you are her grandson, right? I know that. That's why deliberately I am a little tough with you. So with this, we have completed all the properties of image formed by plane mirror. Okay. Now we'll discuss the difference between a real image and virtual image.
So true. Who asked you?
मैंने पूछा जो I was talking just see how
You were talking to me and asked you.
it's
Types of images. One is
Virtual image.
real image. Real image.
you don't have
Autistic.
you only submit
By that you mean you are autist.
no
Now you already have some idea about virtual image. Tell me, what is virtual image?
form
The
behind
image.
it.
So it forms
Behind.
behind.
It's irritated.
Two. It is direct. It is of same size. Is it of same size always?
No.
Can be bigger or smaller also, but of same size. It is of, okay, it is right, of same size. In case of plane mirror. But magnified or diminished. In spherical terms. So it will depend on the type of mirror. So in spherical mirror, it will not be same size. It will be erect, but not same size. Okay. Then the fourth property is
It cannot be obtained on screen.
it cannot be obtained on a screen.
Just see
Who was?
don't ask you
Who asked you?
don't ask you don't ask you I it's like digging in your butt.
Okay, fourth is this, it cannot be obtained on a screen. But where is it obtained?
Behind your
So, like you are watching yourself in a mirror
On the
and
silver.
you send your brother behind mirror, will he find you there?
No.
So where is it obtained? That's the question. So it is obtained at a point,
In point
it
of
is
incidence.
obtained at a point where when the reflected rays are extended backward, okay, it is obtained at a point from where the reflected ray appear to emerge from. Okay? So it will take some further explanation for you to understand. It is obtained. Write all these points because this is the fundamental knowledge needed for you to understand this chapter further. It is obtained at a point from where the reflected rays appear Okay? It will become clear when we understand it with the help of a diagram. So it is obtained at a point from where the reflected rays appear to emerge or diverge. Okay?
Yes.
Okay. So then what is real image? ये behind था तो ये क्या हो जाएगा? Front.
Front of the
Okay? Forms in front of the
17.
two. What is it?
It is upright. No.
Erect means upright.
It's
Inverted.
yeah.
Okay, it is inverted. What else?
It is smaller.
Always. Smaller means diminished.
Yeah.
Is it diminished always?
No, maybe magnified.
So maybe diminished, maybe magnified, maybe same size also.
Its size varies.
Yes. It can be of same size, can be bigger, can be smaller. Okay. Image size. Size can be smaller, bigger, or of same size. With respect to object size. Size depending on its so depending upon where the object is placed in front of the mirror. Okay, the image will be smaller, bigger, or same size. It depends on the placement of the object. So which we will see when we'll discuss spherical mirrors. 4. Can it be obtained on screen? Yes, it can be. So real images can be obtained on screen. Real images can be obtained on screen. Can you give me an example of real image?
On the spoon's magnifying glass.
Spoon.
Get a reflection of the
Car mirrors.
That you get on the plane mirror also.
Car mirrors.
How is that different than the image obtained in spoon?
Spoon is important. You are magnifying glass.
The car mirrors of the car.
Yes, movie theater. You are seeing the image on the screen. When the projector light projects, the image is on the screen. That's real image. But you see it upright. Yes? How you see the images upright?
Then the projector would have
Ah. So in the projector, the reel is played opposite. Then you see the image as inverted. Do you get it? Final image is obtained inside your eye, retina of the eye.
Yeah, that's inverted.
Yes.
That's why you can see it.
Retina image is inverted,
Yeah,
but
so-
the brain processes it right.
Yeah.
बहुत गड़बड़ है real life में. Crazy man, you have a bunch of crazy stuff inside. Okay, fifth. Can be obtained on screen. Fifth.
I'm writing now. Yes.
No, he's imagining his blind, but he's not.
He took my same that you are.
Because you are not writing, that's why maybe. Give him this pen back.
You see. Hey, no, I want that one.
Now the question is, where the real image is obtained? Now see, where is the virtual image obtained? Like from the mirror, when the reflected light comes towards you, right? Those rays are actually diverging. So when you extend it backward, so it will appear to be emerging from some point. Okay? In this case, after reflection, the rays will actually physically meet. यहाँ पे rays are not meeting; they are diverting away. In case of virtual image formation, the rays are diverting away. But in real image, the rays will converge. Here it is diverging. Here the reflected rays will converge. So it is obtained at a point where the reflected rays converge. Converge. Or intersect each other. ठीक है तो रियल इमेज का ऑर्गेनिक कहाँ पे होता है where the reflected rays cut each other or intersect each other और वर्चुअल इमेज का होता है where the reflected अभी वर्चुअल इमेज में reflected rays ऐसे आता है so when you extend it backward behind the mirror so they will meet at some point so when the observer sees the image he feels that the rays are coming from behind the mirror that's why the virtual image is obtained okay. So we will see the example of this one right in case of plane mirror. This example we'll see in case of image formed by curved or spherical mirrors. So यहाँ पे sixth में लिख लो formed by virtual images formed by plane and spherical mirror. दोनों बनाते हैं. ठीक है virtual images obtained or formed by all plane as well as spherical real image is formed by spherical mirrors only स्फेरिकल मिरर्स में केवल कौन सा इमेज होता है? रियल इमेज यू विल गेट ओनली इन स्फेरिकल मिरर्स, प्लेन में बनता ही नहीं। ठीक है, ये सब चीज दिमाग में रखना। ओके, नोट आर यू एबल टू डाइजेस्ट टिल हियर? जो भी हमने डिस्कस किया सब समझ आ गया? ठीक है, तो रियल लाइफ में इनफाइनाइट रेज ट्रेवल बाय द रिफ्लेक्टिंग सरफेस, लेकिन हम जब इमेज बनाते हैं तो खाली दो रेज चाहिए हमको। To draw the ray diagram for image formation, what we need? Two rays, the incident ray and the reflected ray. मतलब दो rays का, दो incident ray और दो reflected ray, उससे we can figure out the nature of image. ठीक है? और क्या चाहिए हमें? Normal. क्या चाहिए? Normal. क्या बोल रहा है? ओए, क्या चल रहा है? Change the position, both of you. चलो, you sit here. दोनों को चैन नहीं, बेचैन हाथ। चलो, नोटबुक लो, पेन ले लो। ओके, तो आई होप रियल इमेज एंड वर्चुअल इमेज का डिफरेंस समझ में आ गया। ठीक है, नाउ वी विल सी फॉर्मेशन ऑफ वर्चुअल इमेज बाय प्लेन मिरर। देखो स्टेप्स में वर्चुअल इमेज, तो इसमें we will see two cases. We'll see two cases. First case, the object will be point object. Okay, case one. Point object. Okay, so let us say this is our plane mirrors. And we have a point object O. Okay, so what are the conditions? The image will be obtained at equal distance behind the mirror. तो कैसे पता चलेगा? देखो, we'll take two rays. Let's take these two rays as so this is the first incident ray and this is the second incident. I said with the help of two rays I can actually find out what is the image position. Okay. So these are my 2 point of incidence. So first thing I'll do is I'll draw normals. So which is, so this has a small angle of incidence, this has a bigger angle of incidence. Correct? What is going on? Hey, how did you change the place? Go back. Settle down fast, नहीं तो मैं बाहर निकाल दूँगा अभी. No compromise with learning. Wait. What is here? This is angle of incidence I1. This is angle of incidence I2. Now what will happen? You'll draw angle of reflection which is equal to I1 in the first ray, and here you'll draw angle of reflection R2 which is equal to I2. Correct? So where will it? ये तुम्हारा यहाँ होना चाहिए ना, यहाँ देखिए। तो इसका रिफ्लेक्शन का एंगल कैसे बनेगा? ऐसे। Are the reflected ray looking diverged? It's too big. Okay. Are they looking diverse? Are they parallel or diverse?
Diverse.
Diverse. So then what you're supposed to do is you're supposed to extend it backward. Okay. So when you observe from this side, from front of the mirror, you feel that this image, okay, let's call this image as O dash. Have you understood?
Yes, sir.
These reflected rays appear to emerge from O dash. These reflected rays appear to emerge from. I will slap you really hard. No, I'll do that. Enough. I'm watching everybody. I'm watching everyone. Okay. Nobody will be saved. So what did I just say? Why virtual image at O dash? Because these reflected rays appear to diverge from O dash. तो वो point कैसे मिला? So reflected rays को you will extend backwards
With dotted lines.
with dotted lines. Okay? That is why it is virtual, because it's not real. It's not real rays. That's how when you send somebody behind the mirror, you will not get anybody. ठीक है? समझ आ गया? Case one was point object. So it is satisfying all the criteria. You raise it at the same distance behind the mirror. Like if we call this as P. So OP is equal to O dash P, right? Then it is obtained at this point. So these reflected rays appear to emerge from here. How did I get this? I just extended backward the reflected rays. So they meet at O dash. So wherever those extended backwards rays meet, right? Or wherever the reflected rays appear to diverge from, at that point the virtual image is formed. Okay. Now case 2, object image formation in case of a extended object. Real life में object points है थोड़ी होता है. Real life में you have object which has well defined dimension, extended object, बड़े object. Okay. So let's take the example of a scale or some rod. Case 2 is extended object. Extended.
I know that.
This is a bad company. Huh? Don't make me pull you up towards the end of the class. Only 30 more minutes to go.
15. 14.
No,
10:45.
come on.
Yeah, it is still 10.
So I'll extend it by 15 minutes. All the wasted time with interest will be doubled. So you do not pay attention to each other's distraction. Okay. So extended object. I'll do that. Huh? If you don't improve, I'll have to do that. So extended object में, let us say I have a rod. Let's say A, B. I have object AB. So now what do I do?
ray from any point. No.
Yes. So I'll select 2 points. Let's say I make it slightly small for the sake of better ray diagram. So imagine the 2 points are this: the top of the rod and the bottom of the rod. I'm taking two ray diagrams. Now I know the image formed is. So what you have to do while drawing the ray diagrams in your examination? So you know that you draw the perpendicular here with the help of a scale and extend it backward. So you know that the image of this point A has to be somewhere on the perpendicular. Measure this distance, mark the point here. Let's say this. Okay. Now you got 2 points. One, the point of incidence, and this. So now keep your scale like this. Okay. And start drawing the dotted ray here. Dotted ray here. This is some trick I'm telling you so that your ray diagram is perfect. And then here you draw a solid line. Okay, here you have a solid line. Again, place your scale on these 2 points and draw the ray diagram again. This will appear diverged. Okay, likewise here also. So you got the image of A. Similarly, draw a perpendicular from here. Do not draw, just judge. And then whatever point of incidence you get here, mark a point here behind. Somewhere. And then यहाँ से भी कहाँ जाएगा ऐसा. This will be B dash. So what is your image here? Dotted rays means imaginary line. So it's a virtual image, right? It's not a real image. So wherever you have virtual, all those rays has to be dotted. So normal is also a dotted imagined line. So extended object, right? This is how you draw. Okay. So start and end the 2 points of the image, and then if you would have taken any point here, then take 2 rays. So every point will be reconstructed. So it fills the entire line. And we have taken only 2 rays. So what we have learned here? To draw the ray diagram for image formation, we only require 2 rays and see their behavior, whether they are diverging or converging. So in this case, the reflected rays are diverging. Therefore, it will be forming virtual image when the reflected rays are extended backward. They will be meeting at some point. So they appear to be diverging from that point. See, it is obtained at a point from where the reflected rays appear to emerge or diverge from. That's where the virtual image is formed. So it appears to emerge from A dash and B dash. Okay. Likewise, every point within AB on this side and every point between A dash B dash on the other side. That's how the full image will be constructed. Okay. So I'll give you the example of real image, but that we will study when we study the image formation by spherical mirrors. Okay. Next, I'll prove that angle I is equal to angle R. So far we have said angle I is equal to R. We'll mathematically prove it. Okay. So let's prove that. So like we have done this, we can also obtain the image for object P. उसमें भी वही करना है from the top and the bottom. So P will appear like this. Every point you take, the image will be equal distance on the other side. Okay, that's how it will be constructed. Have you understood now? So inverted diagram you have to draw on the other side. Okay, so let me give you that. Let's say you had a letter P. ठीक है, उसका इमेज कैसे आना चाहिए? उसका इमेज आना चाहिए उल्टा. ठीक है, तो इसमें भी तुम्हें क्या लेना है? दो रेज लेना है. यहाँ से ले. यहाँ से भी लोगे. ये तुम्हारा हो गया ना, P का टॉप एंड बॉटम और ये बीच का हो गया, ऐसे निकाल लो. तो जो मिरर के ज्यादा नजदीक है उसका इमेज मिरर के ज्यादा नजदीक होगा, तो उल्टा हो जाए. ठीक है, इमेज में ऐसा मत कर देना गलती से, इन्वर्ट हो. ठीक है, समझ आ गया? बिकॉज जो भी पार्ट है जहां से रे इमर्ज हो रहा है इक्विडिस्टेंट बना है, इक्विडिस्टेंट तो उलट जाएगा. ठीक है, so let us prove that angle I is equal to angle R. वो लास्ट है हमारा. इसको मिला दें. ठीक है, show that हमने लॉ में यही बोला था ना, angle I is equal to angle R. तो उसके लिए हम क्या करेंगे? Let us take an object. ठीक है, let's take the two rays as one as along the normal. So when the ray is incident along the normal, what is angle of incidence? Zero. Because angle is with the normal. So here the ray will go back on the same path. Reflected ray also will be zero. So it will go back on the same path. Whereas here, if you draw the normal, here. So what is it? This is angle of incidence. This is angle of reflection. So let's now name. This is object. This is, let's call P. Let's call this Q. Okay. So we have to prove. Let's call this point as Q, and this is mm dash. Now let us mark this as O dash. ठीक है. So now we'll apply properties of parallel rays and the angle found between two parallel rays and a transversal. So taking O dash Q as transversal and this normal and this as parallel rays, this has to be angle R. Correct? These are parallel rays. This has to be angle R. Corresponding angle. And this has to be angle I. This is angle I, alternate angle. Isn't it? This has to be 90 because normal. What is it? 90. And this side is common side. PQ is equal to PQ. Okay? PQ is equal to PQ. So are these two triangles similar? Are they similar? देखो, and this is also equal. By the properties of image formation. So OP is equal to OP dash. During image formation by plane mirror, OP is equal to O dash P and PQ is equal to PQ. And this angle is equal 90, both 90. So by side angle side rule of congruency, these two triangles are congruent. Correct? So for congruent triangle, corresponding angles also must be equal. By properties of congruent triangle, thus I can prove that I is equal to R.
Which lines are parallel?
OP and NQ. OO dash and NQ are parallel. So OO dash parallel to NQ, isn't it? Because this is normal. And this is ray incident along normal. They are parallel. ठीक है ठीक है तो इसका प्रूफ तुमको एग्जाम में नहीं पूछेंगे व्हाट आई एम ट्राइंग टू से इज बाय जस्ट प्रूविंग triangle OPQ is congruent to triangle O dash PQ. Just by proving these two triangles congruent, you can prove that angle I is equal to angle R. Not expected in exams, but this is how you can prove it. Okay, I'll see you in the next class. We have class tomorrow and day after tomorrow as well, right?
In the morning?
Sunday also, yes, same time. Huh?
Sunday also?
Yes, it
For
is.
physics only?
Yes.
अच्छी बात है मैं जा रही हूँ. Hello. Catch.
Hey, Satya, give na. You should give. Hey, give. I'm not doing. I'm not doing it. Give.
Oh, sure. You not eating now.